So today our featured speaker is Gina Colfer, Sustainable Solutions Agronomy Manager for Wilbur, Ellis, a company that sells plant protection, nutrition, seed, and technology to organic and conventional growers, both in the U.S. and internationally. And I'll just comment that this is the first time I've invited a featured speaker from the agriculture sector to share their IPM work with our group. And as you all regulars know, here in San Francisco, we're often focused on urban IPM. We don't produce agriculture, but there are a couple reasons why I thought it was important to reach out to Gina to ask her to share her work with us. First, she earned the Lifetime Achievement Award from the California Department of Pesticide Regulation for her work developing and implementing safer, more sustainable IPM practices in agriculture. And that was 2024, right, Gina? I think it was last year.
2023. For 2023, I was awarded in 2024. Yes.
Right. Okay. Work in 2023, awarded in 2024.
For a lifetime of work. Yeah.
Right. Yes. Thank you for that refresher. Yeah, and the second reason I wanted to invite Gina is, she's working on sustainable pest management methods for production agriculture, which includes fruits and vegetables, and we all need to eat, and the way that we fuel our bodies is really important, and the way that food is grown is really important and matters. So there's that. Plus, of course, California grows a significant amount of produce that's distributed around the country. So I feel that our state's in a position of power to really lead by example when it comes to sustainable pest management and pest prevention in production agriculture. So let me share a little more background for you all on Gina. Her life in agriculture started at home, growing up on a family farm on the Central Coast of California. She attended Cal Poly San Luis Obispo and majored in crop science. Once out of college, she started her career as a licensed pest control advisor on the Central Coast, working on cool season vegetables, berries, and grapes. Gina then went on to work for a large organic vegetable grower / shipper of leafy vegetables, managing field food safety, regulatory compliance, and agronomic research and development. And now Gina is with Wilbur Ellis, working to increase their footprint in the organic sector, offering new and more sustainable plant nutrition products, cover crops and insectary habitat, biologicals, and new technologies that enable the grower to farm more efficiently with a greater ROI. And so today we're going to hear Gina talk about irrigation management and impacts on pests, biological controls, weed management, an organic spray program, and soil health. So I'll pass it over to you, Gina.
Great, thank you so much. And I am going to put up my PowerPoint presentation so we can walk through this together. Great, can everyone see my slides? Shobha, can you see my slides? Okay, great.
I can, it's good.
Okay, well, thank you so much for having me here today. I'm really excited to present to your group of people interested in integrated pest management in more of a landscape and urban environment. But I think there's a lot of crossover for these practices. So again, my name's Gina Colfer. I'm a licensed pest control advisor and certified crop advisor, and I work with Wilbur Ellis Ag. So Wilbur Ellis is a company that we help growers find solutions for a lot of their issues. And we are a national company, so we have over 180 branches nationwide. I am the Sustainable Solutions Agronomy Manager, so really tasked to help finding new products and innovations for growers to help them farm more sustainably. So I wanted to really highlight the difference between organic and regenerative and sustainable. And then there are other, fair trade and things like that. But really, I wanted to highlight these three because they're the ones that are really in the news and making being talked about, and more of a push for these type of products. So I really want to drive home the fact that organic is a labeling term that was voted into law in 1990 by the US federal government and then implemented with oversight by USDA in 2002. So they took comments and worked on it for 12 years prior to them implementing it. And so a lot of time and effort went into producing these guidelines. And so these guidance documents and the list of approved and prohibited substances that are allowed in organic farming are available on the USDA website under the National Organic Program list of allowed and prohibited substances. So it is backed by the federal government as a labeling term. You cannot put organic on your product, the label organic on your product, if it is not certified by a certifying body. Regenerative is also a labeling term and a certificate that's implemented by private companies and nonprofit organizations that have as their main pillar soil health and animal welfare. The Regenerative Organic Certificate, or ROC, is the only certificate offered for regenerative that has organic as their baseline. So you have to be certified organic before you can even apply for a ROC certification. So there is some government oversight with the ROC certification, but the rest of the regenerative labels, they do not have government oversight. Those are all private and nonprofit organizations. And then sustainability is really kind of the same when it comes to there's no government oversight. It's more a labeling term and certificate that's implemented again by private companies and nonprofit organizations that promote sustainable practices on the farm. So like renewable energies, reduced water and nitrogen use, also integrated pest management, and a lot more that dive into not necessarily, using organic products or practices, but utilizing more sustainable practices where you're trying to reduce inputs and then and using renewable energies. But then also large buyers like Walmart and Costco and Kroger are asking suppliers for what their sustainability metrics are. So like they're asking the big shippers like the Taylor Farms or the Doles of the world, what are you doing to be sustainable? And then what are your growers doing that are also increasing sustainability on the farm? So there are a lot more ask now of growers of what their sustainable practices are on the farm. And a lot of growers are looking at that and saying, well, where can we then comply? And so a lot of it is reducing some of the more high risk pesticides. So trying to incorporate more biologicals into their pesticide integrated pest management programs. So it's helping the grower. That push for sustainability is also pushing the grower to kind of go out of their comfort zone and try some of these new techniques that fall in line with what organics is trying to do. And then I just really want to dive into how is organic defined and how does it set itself apart from conventional farming? So no synthetic substances, GMOs, sewage sludge, or irradiation is allowed in organic farming. That's just straight across the board. The National Organic Program operates under these guidelines and then has a generic products list, which is also available on their website. And then all of the organic inputs that are listed by the NOP must be reviewed and approved by OMRI, WSDA, and CDFA OIM for organic fertilizers. So if a manufacturer takes a generic product, like say a pyrethrum is a generic product that's allowed under the NOP because the pyrethrum is from natural flowers. Then that company can manufacture an organic pesticide, but it must be approved by OMRI, which is the Organic Materials Review Institute, or the Washington State Department of Ag, to comply that it is truly an organic substance. It's not synthesized in any way. And so that also, you can go to the OMRI website and they have a full list of products that have been approved by their certifying body. And then an organic grower, so there's a 3-year transitional period from being a conventional farmer or that land having synthetic materials applied to it to becoming organic. So that 3-year transition period really is for the grower to learn how to farm organically, because there is a kind of a steep learning curve where there's a lot of agronomy involved. You have to understand the whole nitrogen cycle and the pest complexes. You can't really, like in conventional, you can kind of spray your way out of a problem, whereas in organics, you really can't. It's about prevention and setting good soil health. So that's a 3-year transition period for that grower. But they are not paid a premium during that transition period. So it's a really tough, hard pill to swallow to go through that 3-year transition period. So we as a company, try to support our growers and try to keep those costs down. And then all organic growers must be then certified by one of the 80 certifiers that are approved by the National Organic Program. And an example is CCOF or QAI or Oregon Tilth. There's 80 certifiers in the United States that will certify a grower that they are organic. And they come in, those certifiers come in and do a yearly paper audit, and then also a yearly physical audit of the farm that is organic, that's being certified organic. And then that happens yearly. So every year they have to be audited to those organic requirements. And again, just organic is the only certificate with the federal government backing it, and organic integrity is a priority for the industry because that is how they set themselves apart. So it's really important that we as growers and consultants adhere by the rules, because integrity in the organic label is really important. It's the most trusted seal in the United States. So then as a company, if we are recommending an organic product or input for the grower must have that on their organic materials list. So every grower has their own unique organic materials list. And so prior to recommending and applying a product onto organic ground, it must be approved by the certifier for that grower to be able to use that product. So they just can't, some sales rep can't come in and say, oh, this is an organic product and yeah, go ahead. No, there are stop gaps. Like the certifier has to review that product. Even if it's OMRI approved, they still have to approve it for that specific grower. So it's a grower by grower approval process. And so there's a lot of hands that touch, an organic grower's organic system plan. And so, there are regulations, but that's why we pay more for organic, because it is a trusted seal, because there are all of these stop gaps put in place. And then if a product is applied that's organic, the equipment trace back is also really important. And so like my company where I'm located in the Salinas Valley, we do applications for our growers. So we do recommendations and we do applications for our growers, organic applications as in, preventative pest management. And then also fertilizer. So like you see this ball tank, that's a liquid injection system that's going out onto that lettuce crop. But this equipment needs to be marked as organic only, and there's got to be a clean out procedure. If the equipment is not dedicated as organic, there's a standard operating procedure that's written in to our system, and then a clean out procedure demonstrating what happens between a conventional farm to an organic farm with that equipment. So really important when a grower is going through their audit, they have to demonstrate what equipment was used on that farm. So really you've got to dot your I's and cross your T's to make sure that equipment is either dedicated to organic or you have an appropriate clean out system for that equipment. And then every grower has an organic system plan. So it really, it's intimidating when a grower goes to, become an organic farmer and start to do all of the paperwork because they have to fill out this very long and involved organic system plan. But it really boils down to what is your nutrient management plan and crop rotations? What's your cover crop and compost use plan? What's your biodiversity and conservation and natural resource monitoring plan? Because organics, we want to embrace biodiversity because that's part of the prevention for pest, and then also your pest management prevention and monitoring plan. And I'll dive into that a little bit. But first, we want to talk about fertility management because in organics, we really want to focus on the soil and how important carbon is in the system. Because with conventional growers, they're not doing a lot of cover cropping or composting. They rely really on synthetic fertilizers that don't contain really any carbon. Urea has a little bit of carbon, but not a lot. But mainly it's synthetic fertilizers. So it's like I use the analogy, it's like taking vitamins to try to stay alive and feed yourself. It's not sustainable in the long run, and that's what we're starting to see is there's more diseases and pests in the fields, and we're kind of on this vicious cycle of trying to keep up. But what we're seeing is when you do get organic matter into the system, it changes how your plants respond because organic matter is the food source for microbial populations in the soil. And really, we know so little about these microbial populations in the soil. We know about maybe 5% of what's happening in the soil when it comes to microbes. And the populations in soil, when, everyone probably knows this in this talk, but I just like the example of, 1 teaspoon of soil contains more soil organisms than there are people on Earth. So when you think about that, when we are using herbicides and fungicides and insecticides, we're really depleting those populations and reducing the diversity of those microbes. So when we add carbon and organic matter into the soils, that's the food source. So if we can reduce using those harmful pesticides that reduce diversity in the soil and start putting in more carbon that increases diversity and promotes biodiversity in the soil, then we can start filling those niches with the good guys and out competing the bad guys. So then that's when you see soil diseases start to diminish because those beneficial populations start to outcompete those bad guys like Pythium and Fusarium and Phytophthora. So that's really the key to getting organic matter into the soil. And I know this is a wordy slide, but there's some cool information on here where, okay, soil organic matter contains approximately 58% carbon, but within that soil organic matter, 35% is active. So that's the active form of carbon that microbes are eating. And then 65% is passive. So that kind of goes into the recalcitrant component of carbon where it just starts to store. So we're storing carbon, and that's what we want to do. We want to pull carbon out of the atmosphere and store it in our soils. And, if we have more roots in the ground, plants growing, that's how you pull carbon also out of the atmosphere and get it into the soil, because you're getting 25. So your plant, that's what they're feeding on, right? CO2, they're pulling it in. 25% of that carbon that's brought in by the plant is then put into the soil to feed those microbes. And it's all a synergistic relationship that happens with the carbohydrates that are released into the soil. So there's enzymes and phenolics, and they signal microbes to help that plant look for phosphorus, look for micronutrients, look for these good beneficial organisms to help that plant be healthier. And so cover crop really is kind of the low-hanging fruit of how to get massive amounts of carbon into your soil. And cover crops, there's so many benefits to having a cover crop on the farm. The top picture shows a ladybird beetle in the cover crop. And this is on a, farm in the Salinas Valley. And if you walk through a cover crop during the winter, it's loaded with ladybird beetles out there. And so it's a refuge for beneficial insects where during the winter, they don't have a lot of place to refuge, because a lot of growers will also leave the ground bare because they want to get back into that system early in the spring, and think that they can't get in because it's going to be too wet. They can't work that cover crop in. But we have researchers doing a lot of work right now showing the examples where cover crops can fit into the system and how growers can incorporate them into the soil without losing time, but then reaping the benefits of that carbon. So cover crops will increase water holding capacity and water use efficiency, help increase infiltration, reduce erosion from water and wind, introduce carbon, and increase so if you increase your organic matter content by 1% on the farm, and it takes time to do that if you're cover cropping and you're adding carbon type of products into your soil, you can increase your organic matter content by 1%. You'll increase your water holding capacity by 20,000 gallons per acre. So that's a really amazing stat when we're a water starved state. So we need to figure out, how can we hold on to more water? Well, let's try to increase our organic matter in our soils. And then also it's adding 5 tons of carbon to the soil. Like if you have say a 4-foot tall grass cover crop, you can get up to 10,000 pounds of biomass, which is then equates down to carbon. So I just wanted to point out this middle picture. This was a trial that we did in almonds, and on the row on the right where you can see kind of the residue, that was a cover crop. And then on the left, that was left fallow. So I came in to evaluate this the day after he disked the cover crop and then flood irrigated. And I walked across the row, and you can see my foot tracks where it was cover cropped. It was like a sponge, right? It was just spongy, and it had a lot of biomass in the system, and the water infiltrated down really well. And then I get over to where it was not cover cropped, and I sunk up to my ankles because that water just, there was no holding capacity. It just kind of waterlogged that whole system. There were no air pores where there was air on the other side. It's like a sponge, right? Where you have this residue incorporated into the system versus kind of just this flat plate that has water in it, and you're just going to sink down. So that was a few years ago that we did that. I'd say a few years ago, like 10 years ago now. And it was a really great aha, moment for me and the grower. And the grower, this was an experiment that he ran. And from then on out, he started planting cover crops every winter. So it's running trials and trying to figure out what works in your system. And I'm a huge proponent for that, um, and Karen Ross, who is our great Secretary of Agriculture here in the state, she's said in the past, when you've seen one farm, you've seen one farm. So everyone's unique in how they farm. Their soils are unique. Their crops are unique. We have over 400 agricultural crops in California. So there's no cookie cutter way to do anything. It really is a, field by field basis of how you manage your crops. And then this was a trial down on the bottom where we did a cover crop trial where it was a conservation tillage. So we had a great cover crop trial of rye that was about 3 feet tall, flail chopped it, and then disked it in and did 3 passes compared to the normal conventional tillage of 10 passes. So we did 3 passes. You can see the residue on the surface of the field, and then we transplanted cabbage into this residue. And that residue stayed on top of the surface of the soil and preserved the moisture. So we had better moisture capacity in that crop versus the no cover crop, and less weed pressure because we had that mulch over the top. So it's just, running all these different trials and learning and teaching these growers where cover crops can fit into their system. And now, in the Salinas Valley, we are definitely increasing our cover crop usage from, it's been less than 5%, consistently throughout the years, to now it's starting to bump up into the 7, 8, 9% cover crop in the Salinas Valley. So that's been a big move for us, and in the positive, because again, it's about getting carbon into the system. And then this was just another little trial we did to help one of our growers demonstrate the benefits of cover crops. So we know what the benefits are, but how do you measure them? So this was a moisture probe that we put in the soil. It's called Probe Schedule. It's one of our technologies that we have. And so you can see on the left, this was a fallow field versus a cover crop field with triticale. And it got we had a lot of biomass. The root system went down really deep. And then I just want to go over some of the data that we were able to collect. So on the left is the fallow field, and on the right is the cover crop field. And this is the EC of this field. So the electrical conductivity, or the salts of this field. And you can see in the deeper depth, so this is 28 to 30 inches, we had, some salt readings up to 2 decisiemens per meter, which you start to get crop restriction at that 2 decisiemens. Whereas in the cover crop, you can see how that water infiltrated down and leached out the salts. So we were able to stay below that 1.5 EC. So really, this was to show, or this was to demonstrate to the grower the benefits of cover cropping, but then also the benefits of tracking what you're doing, because then they were able to go to their shipper and say, this is why we want to cover crop, and demonstrate to Walmart and Costco and these different companies that are talking about sustainability why it's so important to cover crop, because it is another crop. It costs money. You have to manage it. Sometimes it messes up your planting schedule. So it's really important to understand what the benefits of a cover crop are. And if you can reduce your salts during the winter, so you're not going into the spring with high salts already, because this was during the 23-24. So last year it was during, well, I guess it was 24. So January 10th through April 14th, we got a lot of rain, right, during that time. And so it was really, it really showed how the salts could leach out with a cover crop. Whereas and this is a heavier soil, they just stayed in that growing profile, that where the roots are. So really a lot of benefits. As you can see, I'm a cover crop proponent. So then also with organics, irrigation and nutrient use efficiency is also really, really important. We don't want to over apply our fertilizers because they are expensive. A lot of the organic growers will use pelleted chicken manures, but then also animal proteins, as in meat and bone meal, feather meal. They'll even use blood meal. And these are put into the pellets when they're manufactured. So those proteins are put into the pellets. And so, you've got anywhere from, say, a 442, which is a chicken pellet, to an 851, which is a meat and bone meal pellet, to a 1300, which is a feather and blood meal pellet. So it kind of runs the gamut of what kind of nitrogen you put out, but the growers will put those out on the front end because they also contain a lot of carbon. And then we'll spoon feed with a liquid nitrogen, um, to get the nitrogen when the grower needs it. And I just put this lower picture in because you can see where there's water accumulating, and this is a posted field. This is a conventional field. It had just been sprayed, but you can see the salt build up. So you see that white on the surface of the beds. So that's salt buildup. So that'll restrict the root development and uptake of nutrients. And then also when you have water sitting in a low area like this, you can see that these plants, they just are stunted and have restricted growth. So this is also a area where disease could start and then spread through the field. So that's why, it's really important to have really good irrigation use efficiency and nutrient use efficiency. This was a trial that we did. This was actually a conventional trial where the grower was just using synthetic, really CAN 17. He used acid up front, and then he'd go with the calcium ammonium nitrate through the season. And we talked him into using a more urea-based type of nitrogen, but then also add humic acid, which is a carbon-based ore product that's been broken down, solubilized with potassium hydroxide. and then also a consortium of 7 different bacteria that help to mineralize and solubilize the phosphorus and micronutrients that are tied up in a high pH soil, which in the Salinas Valley, we have really high pHs. So the treatment, the product is called N-Power, which is a 2700. This is not organic. Right? I do a little crossover. I do organic and conventional, but I just wanted to throw this trial in here to highlight the benefits of humic and microbes that are designed to help mineralize the soil. So it was N-Power 2700, humic acid called Puric, and Nutrio Unlock, which is a consortium of 7 different bacteria. But I want to play this video because it is really hard to get successes, but it was really neat in this trial where you could just drive up to the field and you could see where our split was in the field.
Hey,
And
Gina,
it was, yes,
sorry to interject. Before you get to the video, we have a question to just clarify. What does the TRT stand for?
treatment. Yeah. So I'll just, yeah, so the treatment had 24% lower nitrogen than the grower standard, which was with Ag Order 4.0, that's the state mandate to reduce nitrogen by a considerable amount. But like by 2050, what the Water Board, the Central Coast Regional Water Quality Control Board, wants growers to get to is 50 pounds of applied nitrogen per year. So that's going to be a lofty goal, but can we get there? Well, we need to start trying now. We can't wait to the last minute, right? And it's an incremental reduction over the years. So this was a trial. How much nitrogen can we cut back? Well, we cut back from 400 pounds, which is crazy, to 300 pounds. But we had a huge crop. So it's like, oh, we could even back off from 300 pounds. So this was just an example of, trialing it and understanding that it could be done. So yeah, that was just an example of adding carbon and microbes to a system that hadn't had it in the past. And that crop really, really responded to where the grower standard side was kind of really uneven. And that's what they were kind of used to, right? This is decomposed granite that they're farming on. I mean, you can see that soil. It's hard, it's sandy, but it also has little pieces of granite in it. So it just doesn't hold on to nutrients. It leaches nitrogen out through the profile. So the humic acid was able to help hold that nitrogen in place. And we also had a nitrogen inhibitor in the urea product. So it just kept it in place, and that's the goal, is to reduce applied nitrogen. So this was just a great step in that direction, but again, if we don't try it, we won't learn. So I just am a proponent for trialing different products, different methodologies we need to keep progressing forward. And then going back to the organic fertilizers, I just want to talk about the carbon to nitrogen ratio and the effect on nitrogen availability. So a compost is, and especially like the yard trimming compost, where it's a green waste compost, you'll have a carbon to nitrogen ratio of about 20 to 1. So you have 20 carbons to 1 nitrogen. Well, about at that 18-19 to 1 ratio, that's where you start to see nitrogen immobilization. So your nitrogen is going to get tied up in microbes taking the nitrogen to feed and break down that carbon. If you start to go down, and you could look at like that the purple dots, the blood and the feather meal, where we have a carbon to nitrogen ratio more in the 3 to 1, you can see how that nitrogen becomes available faster. So know what type of organic fertilizer you're putting on, what the carbon nitrogen ratio is. If you don't want nitrogen and you just want carbon, then a yard waste trimming is a good way to go. But if you want that nitrogen to be available at a good clip, then you want to go lower on the carbon to nitrogen ratio chain. And then just talking about the microbes and what they're doing. So they interact with the roots, right? And they help to build the carbon, feeds the microbes to build a healthy soil. And that's we hear the term healthy soil. What is a healthy soil? Well, it's a soil that can cycle nutrients really on its own. But when you have a crop where you're depending on a yield and good quality, you're always going to need to add some nitrogen and carbon. It's the carbon nitrogen ratio, right? So I always say you need to add the carbon and the nitrogen. But that healthy soil is a soil that supports really diverse microorganisms. And really the only way you can support diverse microorganisms is to have the right carbon in there. And so what are some sources of carbon besides cover crops? Well, there are humic acids, which are they're mined from leonardite ore and then hydrolyzed with potassium hydroxide. Compost are a great source of carbon, and then they also have good microbial populations in them. But just understand the difference between a manure compost that has a lower carbon and nitrogen ratio to a green waste, which has around 20 to 1, where you may not ever realize the nitrogen that's in that compost. You're just really putting it on for the carbon and the microbes that are in that compost. There are food waste hydrolysates, animal-based proteins like meat and bone meal and feather meal and blood meal, plant-based proteins. So soy protein hydrolysates are really a great carbon source, and plants love soy protein hydrolysate. Biochar and those byproducts. So biochar, I just really want to define really quick. So I'm a fan of biochar in heavy soils and light soils, because what biochar does is it's not so much a food source for your microbes, but it's a home for them, because biochar has a lot of surface area on it, and it's got nooks and crannies. So those microbes are able to house themselves in that biochar, especially in a soil that has low organic matter, where there's not a lot of home space for them, or in a heavier soil that tends to get waterlogged. That creates some air pockets for them to survive in, because microbes are a living organism. Too much water will drown them. Too dry will desiccate them. So they like that happy medium, and they like a place to hang out. And biochar is really a good option for that type of housing. And then also added microbial consortiums and nutrient that help for nutrient mobilization.
Can I pipe up with a question in the
Oh,
chat, Gina?
uh-huh.
Yeah, there's a question on, is there a point when organic fertilizers or manure composts get too hot or may damage a crop?
the salt index. So you really want to pay attention to that salt index and the electrical conductivity. So if you start to get high salts, and so compost, you can get high salts, especially in the manure compost. So you really want to be careful with that. And then also some of the liquid organic fertilizers will have some high salts in them. So I would always request a soil or a nutrient analysis of the product that you're applying, so you can see what those salt contents are of those fertilizers, because it's not necessarily the nitrogen that's burning the crop, it's the salts that go along with that nitrogen. So I just wanted to talk really quick about, so this was in the Salinas Valley back in 2020, but then it also happened again back in 2022. And I don't know if you all remember, but back around Thanksgiving of 2022, romaine and head lettuce cost about $4 a head. And it was because there was no lettuce, because we had a disease complex get us called impatiens necrotic spot virus, which is transmitted by Western flower thrip. And then we had a secondary pathogen that is ubiquitous in our soils, Pythium uncidilatum. It's everywhere in our soils. But what happened is, with the virus in the plant that also translocates down into the root system, the plant was stressed, and its resistance to Pythium got turned down. It's like a dimmer switch almost, where that resistance went from, your lights all the way on because you've got a healthy plant and it's built in that it can resist Pythium because it's just kind of a root nibbler, it's not a big deal, to that dimmer switch got turned down all the way to where that plant was totally susceptible to Pythium. And so this was what most of the lettuce fields in the fall looked like in the Salinas Valley. We just had a complete meltdown of our romaine and iceberg because of this. And it really highlighted the fact that, we are in this monoculture system where maybe our rotations aren't as good as they could be. And then also weeds are a host to impatiens necrotic spot virus. And we had a lot of these host weeds out in the environment. So we were able to come together as a industry and created a task force to help dive into research and really how do we prevent this problem from happening in the future. And knock on wood, we're doing pretty good, but it really is monitoring and preventing the Western flower thrip from becoming infected with INSV. And so it's good housekeeping on the weed side of things, not having, it's all of our common weeds, shepherd's purse, malva, London rocket, oh gosh, I'm drawing a blank, but all of the nettle leaf goosefoots and the chenopodiums, they all are host to INSV. So we were able to, okay, prevention is really good weed management. So what plants do we then want to put in its place? The weeds, right, that are in the ditches, that are in, and what happened is then a lot of growers were like, well, we're just going to herbicide all of our ditches, we're going to get rid of all of the weeds. And so that has helped. But now what we have is bare, I'm getting feedback, is all these bare ditches where we have a lot of erosion, and also the bare ditches were put into effect during the 2006 spinach E. coli outbreak way back when. I mean, it's almost 20 years now. It's hard to believe, where they were thinking, well, we need to just cleanscape everything and get rid of all of the weeds in the ditches, and have clean ditches. But then that is farm biodiversity, which the organics is really trying to promote, because we see where having biodiversity on the farm is important, both above ground and below ground, is at odds with food safety. We want to have ditches that have grasses that are not INSV host, and different floral plants like alyssum that are not INSV host in these ditches. But then food safety comes along and says, well, we don't want to have any habitat in the ditches because it promotes having voles and field mice and deer mice, and then those deer mice run out into the field. Well, we then got together as an industry, and this infographic is actually sponsored by Western growers. And so we're getting Western growers on the bandwagon here to say, okay, food safety people, we need to come together with the sustainability folks, because it's the sustainability folks at Walmart and Costco who are saying, gosh, we need to have grass-lined ditches. But then it's the same company, Walmart and Costco, their food safety folks are saying, gosh, we need to have bare ditches. So we're getting mixed messages out in the field of what's appropriate. And food safety is always going to win over biodiversity at this point, because, we want to grow a safe food for, our customers, of course, absolutely 100%. But now what we're seeing is that research is showing that having more habitat and biodiversity on the farm actually supports better food safety in the long run. Because if you have a bare ditch, what we found with some of the research that's been done is there are more field and deer mice in the bare ditch, and then they move further out into the lettuce field because there's no food to support them in the ditch. Whereas if they have food with grasses and flowers, and that seed is in there, that's what they really feed on. They don't need to move out into the field. So this is just in the infancy stages. We're really trying to, promote this and get food safety and sustainability on the same page, because at this point we have we'll approach growers and say, gosh, we've got, these great habitat seed mixes for our ditches, but they won't have anything to do with it because their food safety people are still saying we have to have bare ditches. We just don't want to really have to fight with the food safety people. And then if there is an incident, then they come back and say, well, you had, grass in this ditch, and it really enhanced the field mice out in the field. So it's one of those ones where, oh gosh, it's this balancing act of how do we make it appropriate for all interested parties. So we're working on it, and this is an infographic that we have, and if anybody's interested in it, please reach out to me. And also any other further questions, I'll have my contact information at the end. But so this is just some examples. I'm a visual person, and I take a lot of pictures, and it's just, up here in this left-hand corner, this is what we have around. So many ranches, there's little snap traps in here for mice. And so you have to have a person coming around and checking these traps literally every day, because if you've got mice in here and it's tripped, then you've got to reset the trap. And then these are ground squirrel holes. And, this is just the norm kind of in the Salinas Valley, but you can see the erosion that takes place. Whereas here's a grass line ditch that one of our growers did. And, it's intact. It reduces erosion of the soil coming off of off of your land. So you're able to keep things on the farm. So this is what we're really pushing for now. And this is not only inorganic, but in the conventional systems too. It just, it makes sense for the grower, but then again, it is more work because you've got to come in, you've got to scrape the ditch, and then you've got to plant the ditch, and then does it need irrigation, and then you've got to mow it. But there's all these new technologies out there to help manage this. And I think I just want to highlight for some of the smaller producers, and there's a company called Farm NG, and they have a little robot called the Amiga, and you can put a mower on that Amiga, and it's like an 80-inch bed sized machine that can, that's remote control, and you can send it wherever you need it. So you can mow, you can put compost out. It has replaceable implements. So it's a really cool device for smaller producers. And then if you want to maintain a ditch, you just send the Amiga up and down this ditch. So I think it's a super cool idea. And then I just want to talk about, our friends, the raptors and the barn owls and the bats and the songbirds. They all help to control rodents. And then, of course, the songbirds and bats help to control flying insects. So a barn owl clutch can eat up to 3,500 rodents a year. It's just amazing how prolific they are. So I'm a proponent for barn owl boxes, and then also raptor perches, but it's, there are specifics to how you want to erect your barn owl box. But I want to point out Wild Farm Alliance. If any of you have ever checked out their website, and they're a great organization that offer excellent recommendations on songbird habitat, raptor habitat, how to build barn owl boxes. And then also they have educational webinars that they offer DPR units for, so alternative pest management programs. So check out Wild Farm Alliance. They're really a great organization. Oh, thank you. So really quick, I want to talk about biological control agents. So they're easy to overlook. They can be really small. You don't understand who they are, but so predators are generalists that attack and consume their prey. And then parasitoids, this is a picture of a parasitoid, which is, reminds me of Alien, where they target specific species, and then the adult will lay its egg inside of the insect, and then that egg hatches and it consumes the insect from the inside out. And then also predators are mainly, the adults are mainly pollen and nectar feeders, but it is also their offspring that are the predators of the insects. So we want to maintain a good floral diversity on the farm, so you support your adult predators and parasitoids. And then they also are very sensitive to pesticide exposure, so try not to use broad spectrum pesticides. These are some insectary strips that we use in organic farming. So this is alyssum in a celery crop, and a lot of growers will just plant a strip of alyssum. every 40 or 50 beds. And it supports, this is a syrphid fly adult. And so the adult syrphid fly looks a lot like a bee, and there's about 30 different species in California. So they range from very small to, bigger syrphid fly. But they're only pollen and nectar feeders. And then they will smell the pheromone of the aphid, and they'll lay their eggs near colonies of aphid, and then those eggs hatch, and it's their larva form that is the predator of the aphid. So the healthier the adult, the more eggs they lay, and then those eggs hatch, and the hungrier those larvae are when they are looking for aphids. So the healthier, the better, right? And I always say, build it and they will come. So if you have an insectary habitat strip in place on your farm, you don't really need to augment with beneficial insects. You can, but it's expensive again, right? And so a lot of growers, they'll just plant the floral insectary strips, and then the beneficials will come on their own. So this is just a good example here. This is a ladybird beetle eating a red aphid on romaine. So again, this is the larva of the ladybug, right? And this is what's eating the aphid. This is actually an adult minute pirate bug, or Aureus insidious, and this is eating a thrip. He's stabbed a thrip. So this is one of the ones where the adults are also predators, but their immatures are also predators. And then this is what a syrphid fly larva looks like. And it's feeding on this cabbage aphid. And then also, kind of, these are looking a little brown. So these are mummied aphids that have been parasitized by a specific parasitoid. And down here in the right-hand corner, you can see where actually the rear end of the aphid has been eaten out and the adult parasitoid has flown out. So it's just really important to have good floral habitat in your system to encourage these beneficial organisms on your farm, because they really are the heavy lifters of controlling our insects. And then we do have, plant protection products. Like earlier in the discussion, I talked about the products that are approved for organic, and there's pyrethrums and spinoscids. Those are more broad spectrums. We are definitely looking at more biologicals that are softer in the way that they kill insects, right? We want to try to get away from the nerve poisons, what the pyrethrum is. The reason it's organic is that it has a very short residual. It's, degrades with UV, so the minute the sunlight hits it, it's gone. Whereas the synthetic pyrethroids last for a long time. They adhere to soil colloids. They can move in the wind. They can move in water. So that's what distinguishes between an organic pyrethrum to a synthetic pyrethrin. It's just short-lived. It's degrades in nature quickly, and it's naturally derived. It's not synthesized. So we'll do spray applications with large booms, ground applications, and we're also starting to look at drone applications. So this is new technology that's coming. Can we be more specific in how we do that application? And then some of the biological pesticides, some are old, some are new. So like the pyrethrins and the spinoscids, those are old, they're more broad spectrum. They are going to ding the beneficial insects. So we're really trying to get away from them. Bacillus thuringiensis, BTs, those are LEP specific. They're a killed bacterium. For our worms, the BTs work really good, and they're really soft on beneficials. They're not hazardous to apply. They're just really specific to lepidopterans. And then the azas or azadirachtin, that's from the neem tree. It's a insect growth regulator and has some repellency activities, and then some of the soaps and oils. Pheromones are really big for confusion. Not a lot of them are organically approved, though, because of the way that they make them. Some are synthesized and some are natural. So it just depends on what's natural, that's organic, versus the synthesized. And then the microbials, those are live organisms like trichodermas or bacillus. They are temperature and humidity sensitive. Some are entomopathogenic, like the Beauveria bassiana. That's a fungi that attacks insects, but it is really light and temperature sensitive. So they're a little bit harder to work with. And then there's botanical oils that have repellency. They also can act as nerve poisons in their contact. And then there's also some ISRs and ASRs that are out on the market now that trigger the plant's natural defense mechanisms. But that's also what we're trying to do with a healthy soil, with the microbes in the soil. Oh, does bacillus pose a risk to native monarchs or butterflies? No, they do not. They're a bacterium that are specific to plant pathogens. So most of the bacilluses are specific to plant pathogens. So I just wanted to talk really briefly about spreaders and how important they are when you are applying a organic pesticide. On the left here, I had a spray bottle sprayed out, and you can see, how water droplets form on a waxy cuticle plant. This is cauliflower, and this water droplet, it'll just bead up and drop off, right? So when you add an organosilicone spreader, it breaks the dyne out of the water molecule, and you get this spreading ability, and it helps get the product where it needs to go. So I have a video that shows how important it is. So this is a hairy leafed leaf surface, and we sprayed a water droplet on it, and you can see what happens. So watch the water molecule. It just dries up on the leaf hair and disappears, and it never reached the surface. So if you're going after powdery mildew and you need to have good contact of that powdery mildew, well, that application didn't do you any good. So this is here an example with an organosilicone spreader. Boom, it gets down to the leaf surface. So just talking about the importance of a good spreader is it could be the difference between if your application works or if it doesn't. And there are OMRI approved organosilicone spreaders on the market. And then I just want to talk really brief. Oh, I don't want to play you again. Let's see. Go. There we go. And crop oil, yes. Yeah, crop oil would work just as well. It helps break that dyne down. I think organosilicone spreaders can be more efficient, where you can use less of the product, where you're talking 5-6 ounces per 100 gallons of water, where the crop oil might be a gallon. So we're looking at new technologies with precision weed management, and that's where a lot of venture capitalists' money has gone the last few years, is in the AI weed management space. And so on the left this is a mantis technology, where we're going in on a direct seeded lettuce and then spraying actually an organic herbicide called well, we use suppress, but there's home plate. It's a caprylic acid combination. And I've found that, out of all of the herbicides, I've done a lot of trialing of organic herbicides, and the caprylic acid combination active ingredient herbicides really perform the best if you are at the right concentration. So this is this is at a 6% concentration, and you can see where we sprayed the lettuce here. Oh gosh, this was about an hour after we sprayed, and this lettuce, because we're thinning, right? We're leaving, you can see we're leaving a lettuce plant here, and then we're going after the weeds and the other lettuce plants that we want thinned out here. So this is a really cool way to do it. This is organic. You know, if you're using an organic herbicide, this is organic technology. And then this is Verdant Robotics here. So this is also using an AI camera technology where they're targeting the weed, and they have dye in here. So this is a purslane. They're targeting the weed and leaving the romaine plant. So you can go in and target these weeds and use a lot less product. You're using a fraction of the amount of product compared to what you would, you know, as a broadcast herbicide. So cool new technologies coming. There's also carbon robotics, which doesn't use product at all. They actually use a laser. So that's a laser beam. Same kind of idea as Verdant, where they're targeting a spray, um, uh, spray, oh, I'm trying to think of the word, spray, you know, target down to the weed exactly. Whereas in carbon robotics, they're using a laser to target that weed exactly. So yeah, really cool technology that's coming. It's here. We've been utilizing it now for, we've been utilizing Mantis for 3 or 4 years now, and the carbon robotics and the verdant robotics of the world, they've been around for a few years now also, and really are gaining traction. They're more expensive. You have to be a larger grower to invest in this technology. But again, that's where FarmNG and the Amiga robotic, maybe you could put this technology on and do in smaller situations. And then just wrapping up, I know, going back, so caprylic and capric acid is from coconuts. So it's like a byproduct of coconut. So I just want to wrap it back all up. And irrigation and nutrient management is key on a grower's organic system plan. Having biodiversity and habitat in place for beneficial organisms is really key in an organic system plan. Having a sustainable integrated pest management program that really reduces the use of these higher toxicity chemistries. Oh, well, in organics, that's mandated, but it's on the conventional side, you know, that's what we're striving for also. And then creating that baseline measurement to track improvements for soil health and irrigation and nutrient use efficiencies, and then also your pest management. And I think that wraps it up for me. So I just want to say thank you to everybody for listening. A lot of information to unpack, I think. But you can also reach out to me. I'm happy to answer any questions. And my email is gcolfer@Wilbur Ellis. So yeah, any questions?